Okay, so the first part of section 4.5 is about solving exponential functions and equations. So an exponential equation is one in which the variable occurs in the exponent. So for example, 2 to the x equals 7. An equation because we have an equal sign and the x appears in the exponent. Okay, so the first thing I want, if you haven't already, is to write down the steps for solving an exponential equation. Okay, so step 1 is to isolate the exponential expression. So you want to isolate the base, the base and exponent on one side of the equation. Okay, step 2 is to take the logarithm of both sides. So you may need to take log base 10. It could be a natural log, or it could be a log with a base. Okay, so you want to take the log of both sides. And then the last step is to solve for the variable. So those are the 3 steps that we're going to use. Okay, so let's go ahead and look at an example. Okay, so here's the first example. So 3 to the x plus 2 equals 7. Okay, so our base is 3. The exponent is x plus 2, and it's equal to 7. Okay, so step 1 is to isolate the base and the exponent. Step 1 is already done for us. The base and the exponent are on one side of the equation. Okay, step 2 is to take the log of both sides. So I'm going to go ahead and take the log base 10 of both sides. Now I'm going to use my expanding rules. I know that if I have an exponent, that exponent can become the coefficient. Okay, so x plus 2 times the log of 3 is equal to the log of 7. All right, and then I want to solve for x. So I'm going to start by dividing by the log of 3 on both sides, so that I am left with x plus 2 equals the log of 7 over the log of 3, and I'm going to wait until the last step to round, okay, and then subtract 2 from both sides. So I found out that x is equal to the log of 7 over the log of 3 minus 2. Okay, in the question it tells us to round to 6 decimal places. So you want to type this into your calculator. So log of 7 divided by the log of 2, and then minus 2. Oh, I'm sorry. And I find out that x is equal to negative 0.228756. Okay, and if I want, I can go back and check my answer. So 3 to the negative 0.228756 plus 2. If you evaluate that on your calculator, it's very close to 7. Okay, let's look at another example. So let's look at 8 times e to the 2x equals 20. Okay, so when you're looking at an exponential equation, it's important to think about what your base and your exponent are. Okay, so in this case, my base is e, and my exponent is 2x, and I have this 8 here that I need to get rid of first. Okay, so that's going to be our first step, right? Isolate the base and the exponent. So I'm going to divide both sides by 8. Okay, so I'm left with e to the 2x equals 2.5. Okay, and because I have an e here, it makes sense to take the natural log of both sides, right? Step 2 is to take the log of both sides. Okay, so the natural log of e to the 2x, natural log and e to a power are inverse functions, so I'm left with just 2x equals the natural log, of 2.5. Okay, and then step 3 is to solve for x, so I wouldn't want to divide by 2. Okay, and if you find the natural log of 2.5 and divide by 2 on your calculator, you'll get something pretty close to 0.4581. All right, example 3 says to solve graphically and algebraically. Actually, we're going to skip this one and jump to example 4. So when you have something like e to the 2x and an e to the x term, you're probably looking at factoring. Okay, so when you have more than one exponent, it's set up like a trinomial. You want to think about factoring. So that is going to be our first step here. And e to the x times e to the x is e to the 2x, right? Because when you multiply, you add your bases, okay? And then I want to think about, I want numbers that multiply to -6 and add to -1. So -3 and +2, those multiply to -6, add to -1. Okay, so I've factored. I know that either this equals 0 or this equals 0 because of the zero product property. Okay, so I'm going to solve for e to the x on both of these. Okay, so we've isolated e to the x on both of these, right? Step 2 is to take the log of both sides. Okay, and the log of e to the x is just x. So x equals the natural log of 3. And then on this one, when we try to take the natural log of a negative, that's something that you cannot do. So this one does not give us a solution. So our only solution is x equals the natural log of 3. So you want to remember to check your answers on these. Make sure that your answer makes sense. Okay, and then the last example I have, we want to solve the equation 3x times e to the x plus x squared times e to the x equals 0. So remember, step 1 is to isolate your base and your exponent. So we want the e to the x by itself. So what I'm going to do is I'm going to factor out e to the x. Okay, and then I'm going to continue factoring here. These both have an x term. Okay, and the zero product property tells us that either this equals 0 or this equals 0. Okay, if I want to solve this one, x would equal 0. There is no x that would ever make e to the x equal to 0, so my only solution from this equation is x equals 0. Over here, to solve for x, I want to subtract 3 from both sides, and I get -3, so I would have two solutions, 0, and -3. Okay, so I want you to go ahead and try these 5 problems, and then we will go over these.
Good job.